Right, in this video, we're going to talk about the difference quotient. It is basically an average rate of change, but, well, you'll see. Let's talk about it. Okay, so say I were to have, I don't know, so I'm just going to draw some graph here, okay? And I would have a point, okay, here on the graph. And so this point is going to be, I'm going to call it x, and then f of x. Okay, so it's just any point that's on the graph. So x, f of x. And then I have another point that is to the right of this point. And so it's going to be x plus h. Okay, so basically, you know, it took me, I got to x here, and then I add on a little bit more, and h is just some constant. So I add on some amount more, and then I get h. So that's x plus h, and then the y is f of x plus h. Okay, so now if I were to find the average rate of change between these 2 points, you know, which would be the slope of that line that I just drew, you know, the average rate of change, between these two would be, you know, f of x plus h minus f of x, okay, so those are the y, the change in y, okay, so f of x plus h, f of x, and then divided by the change in x, which would be x plus h minus x, right? So we have x plus h here, and then x over there. Okay, you know, and this can be simplified a little bit because these x's cancel. So you end up with f of x plus h minus f of x divided by h. Okay, and you know, of course, h cannot equal 0 because if it does, then that fraction would be undefined. So hey, you know, this is the difference quotient. That's what it's. You know, that is the definition of what the difference quotient is. This is it. You know, it's a very special equation, though. And so that's why I'm, you know, taking the time to make a video about it and talking about it. You know, even though you're like, oh, this is just average rate of change. You know, this is nothing new. You just now, instead of a and b, now you have, you know, x and x plus h. But it's the same thing, right? Well, the reason why it's so important, so let's see, if I were to try to redraw this exact same graph, which I can never draw the same thing twice, but I'll try. Okay, so, you know, if h were to become really small, and this is why the difference quotient is so important, so if h were to become really small, the second point could get infinitely close to the first point, okay? And so, you know, if this is when h is very, very small, okay? So when h is very, very small, then, you know, these 2 points basically come on top of each other. And then, you know, the difference quotient, let me write this. This is a very important point. So the difference quotient, when h is really, really small, is basically is the slope at a particular point on the graph. At a point on the graph. So, you know, instead of it being the slope between 2 points, if h were to become really small, well, that was a really bad drawing. Let's see if I can erase that. Okay, so let me try to draw this line. If h were to become really small, it's this line, the slope of that line. So the slope at a particular point on the graph. And that's called actually the slope of the tangent line. So later, as you get, you know, more into math, you will be talking more and more about this difference quotient, and it's a very important thing. I just realized that difference is misspelled up here. There should be a C between. So this is the video on the difference quotient. There should be a C between the N and the E. Alright, so now let's do an example. Okay, so in this example, so we have a function, and we're basically going to find and simplify the difference quotient. So to do this, first I'm going to plug in x plus h into the function. Okay, actually, I didn't need to write that. I'm going to erase that. So I'm just going to plug in x plus h into the function. Minus 2 times x plus h. So everywhere I see an x in the function, so I'm looking at the function, and everywhere I see an x, I'm plugging in x plus h. There's an x there, x plus h. Okay, then minus the original function, basically. All right, divided by h. Okay, I'm going to write the next step in a different color so that it doesn't get mixed up looking. All right, so now let's go ahead and FOIL this, x plus h squared. That'll be x squared plus 2xh plus h squared. Okay, then I'm going to distribute this negative 2 in. So negative 2x minus negative 2h, then plus 1. And I'm going to distribute this negative sign in. Okay, so that would be negative x squared plus 2x minus 1. All that divided by h. I'll write the next step in a different color. Okay, so let's see here. Things start to cancel. This cancels, right? That one's positive and that one's negative, so those two canceled. What else? The positive 1 and the negative 1 cancel. The 2x and the negative 2x cancel. Alright, that's about it, I think. So I'm left with 2xh plus h squared, okay, minus 2h. All that divided by h. Hey, you know, h is in all of these guys, so I'm going to pull out an h. Okay, minus 2 divided by h. Now, these two h's cancel. So, lastly, I'm left with 2x plus h minus 2. And that's my solution.